Hello students. In physics, we study about different types of motion like translational motion, rotational motion, periodic motion, and also non-periodic motions. In the last session, we had learned about difference between speed and velocity. We had also learned few things about acceleration. Golu, do you remember what is acceleration?
Yes, sir. Acceleration is change in speed per unit time. Can I tell, sir?
Yes, Pinky.
Sir, acceleration is change in velocity with respect to time.
Correct. Very good. Acceleration is not change in speed, but it is change in velocity with respect to time. Understood, students?
Yes, sir.
So let us begin with the new topic. Uniform circular motion, which is our today's topic of discussion. So let us start with the topic. When do we say that object is accelerating? Correct. The answer is when velocity of the object changes in given period of time. Now note that change in velocity could be because of change in magnitude, that is speed, or due to change in direction, or also because of both magnitude as well as direction. Now let us take few examples of accelerated motions. The first be a rectangular track. If a person decides to run along this track, he will have to change his direction at 4 different places. And which are they? Point A, point B, point C and point D. So these are the 4 different points where he will have to change his direction. Let us take another example. This is a hexagonal track. If a person runs along this track, then he will have to change his direction at 6 different places. Point A, point B, point C, point D, point E and point F. One more example. This is octagonal track. Now I would like to ask you, if a person runs along this track, and at how many points he will have to change his direction? Correct. Your guess is correct. He will have to change his direction at 8 different places because there are 8 vertices of a octagon. In similar fashion, if I go on increasing the number of vertices, at one point I will meet a circular path. So this is a circular track. Now in case of circular motion, even if the object moves with the same magnitude, its direction changes continuously. I repeat, even if he keeps his speed same, its direction changes continuously. So at no point he will have to keep his direction same. At each and every point he will have to change its direction. Thus, circular motion is an accelerated motion. Why accelerated motion? Because its direction is changing. Let us define uniform circular motion. When an object moves in a circular path with uniform speed, its motion is called as uniform circular motion. The acronym or short form for uniform circular motion is UCM. So how do we define uniform circular motion? When object moves in a circular path with uniform speed. Can we find speed of a uniform circular motion? Yes, there is a relation for it, and that relation is V is equal to circumference of the circular path divided by time taken. And what is circumference of the circle? Correct, 2 pi r. And if t is a time taken, then formula will be V is equal to 2 pi r upon t. So this is a relation for finding speed in case of circular motion. Let us learn more about uniform circular motion with the help of activity. So what is that activity? You have to take a piece of thread and tie a small piece of stone at one of its end. So this can be a schematic diagram where there is a boy over here and he has a thread in his hand with a small piece of stone at one of its end, and he is rotating it. Now, you have to move the stone to describe a circular path with a constant speed by holding the thread at the other end as shown in the figure. So he has to move this thread in a circular path such that stone revolves around the boy. Now let the stone go by releasing the thread. Now at one point of time you have to release the thread. Now can you tell the direction in which the stone moves after it is released? Yes, any guesses? If suppose this is a point where the stone along with the thread is released, and since it is moving in anti-clockwise direction, if it is released at this point, then stone will go in this direction along the tangent of the circle. I repeat, if the stone is released at this circled point, it will go along the tangent in a straight direction. Thus, if you carefully note, on being released, the stone moves along a straight line tangential to the circular path. That's because once the stone is released, it continues to move along the direction it has been moving at that instant. So that's why it moves in a straight direction along the tangent of the circle. Let us see one more example of uniform circular motion. Can you guess what is this? This is a moon revolving around Earth. So this is an example of uniform circular motion. Why uniform circular motion? Because moon doesn't change the speed while revolving around Earth. Now there are few things that you can try it at home. First one is you can write a short note on uniform circular motion, and then there is a problem which is related to uniform circular motion, and the problem reads: an artificial satellite is moving in a circular orbit of radius 42,250 kilometers. You have to calculate its speed if it takes 24 hours to revolve around Earth. To solve that problem, you can use this relation that we have already studied, which is 2 pi r upon t. So that was all for today. Students, if you have any doubts, please feel free to ask me. You can also comment in the comment box. You can ask your questions in the comment box. Okay, so see you in next session. Until then, take care. Bye bye.
Thank you, sir. Bye bye, sir.